All right, day 4 of this unit. Unit 3, day 4. Today is September 7th. Derivative of an inverse function. At a specified point, yeah, that will always be the case with inverses, otherwise it'd be even more crazy. Okay, first of all, a little comment on notation. So 3 to the negative 1 is 1/3. We talked about this yesterday. A negative exponent flips things over. 4/3 to the negative 1 is 3/4. X to the negative 1 equals 1 over x. Yeah, we did that yesterday. That's true. But sine to the negative 1 of x does not mean 1 over sine of x. It means the inverse sine of x. And so it's tricky when you see a function with a negative 1 in the sort of exponent spot. It does not mean 1 over, it means inverse. So the negative 1 only means reciprocal if it's on a number or a variable, not a function. So f to the negative 1, like this, is not 1 over f. It's the inverse of f. It has nothing whatsoever to do with 1 over f. G to the negative 1 is the inverse of g. So, some notation stuff. Alright, but this is calculus, all that was algebra. We'll be finding the derivative of a function's inverse. So we gotta put our symbols on correct here. So how would we write the derivative of an inverse? Well, there's the inverse sign. We use a little marker thing, prime, to indicate derivative. So it's going to look kind of funny. So there's the inverse. There's the derivative of x. Marks all over the place. But that's the derivative of the inverse of f. That's not how to do it. That's just, again, getting our notation right. Okay, a little bit of algebra review here. If f and g are inverse functions, then all the following are true. The best way to remember about inverses, the best rule that works for almost everything, is you switch x and y. Right? If you switch x and y, it's how you solve for inverses, it's how you find points, it's how you handle graphs, because you switch the x and the y. So switching x and y is just sort of the shorthand version to cover everything related to inverses. So if AB is on the curve of f, then BA is on the curve of g. In fact, let's label these f and g. And if this point is AB, then sort of this reflected point over here would be at BA, the x and y traded places. Bullet number 2. The two curves are symmetric to each other across y equals x. I hope those graphs look familiar because this one is e to the x and this one is natural log of x. So the two graphs we looked at the last couple days. And then lastly, this is from algebra and pre-cal. We would make you do this. Like show that f and g are inverses of each other. F of g of x equals x and g of f of x equals x. They undo each other. Okay, we're still doing algebra. That's still not calculus yet. Until now. Now let's examine the derivative of a function's inverse. Okay, so derivatives are tricky, inverses are tricky, so we're going to put them both together and get the derivative of an inverse. Alright, let's find g prime. If f and g are inverses of each other, then f of g of x equals x. Right, we knew that. That's a pre-cal kind of statement. Take the derivative of each side of this equation with respect to x. Okay, so this is maybe new here. But just like you can square both sides or add 7 to both sides or multiply both sides by 3, you can take the derivative of both sides of an equation. That's a legal thing to do. So ignore the fact that this is an equation, because that really does make things look complicated. If I ask you to find the derivative of f of g of x, what rule is involved there? Chain rule. So outside in, f prime, leave g alone, times g prime, times 1 if you really want to chain rule it all the way down. How about the other side? What's the derivative of x? 1. Now let's solve for g prime. So this is a crazy looking equation, but solving for g prime is an algebra step. G prime is equal to 1 over f prime of g of x. Okay, you may not appreciate this statement yet. We have learned something very valuable. Like, yeah, it doesn't feel very valuable right now to me. But inverse functions have reciprocal derivatives. Reciprocal, 1 over derivatives. To me, the easier way to think about that is that a derivative is often written as dy dx. But if inverses are all about switching the x and the y, then that would be, no one ever does this, so I really hesitate to write it. It would be dx dy, which is like, ooh, nobody ever does that, so yuck. But you could rewrite that as 1 over dy dx. So the original, like, we know how to take those derivatives, that's dy dx. But in inverse, after we switch y and x, it ends up flipping the derivative. It might be easier to back all the way up to change in y over change in x. That's where the derivative comes from. If you flip x and y, you end up with the reciprocal. So reciprocal is the name of the game for today. All right, if f and g are inverses of each other, then g prime, so the derivative of g is 1 over the derivative of f, because inverses switch x and y. If AB is a point on f, then BA is a point on g. That's what it means to be inverses. So here's kind of the tricky thing. G prime of B, 1 over f prime, but not at B, you have to switch x and y, f prime at A. Okay, my suggestion for all of these problems is to make a table when you get a derivative of an inverse problem. And lay out the table like this. You've got f and g, you've got a point, and you've got, I'll just call it y prime. I don't want to call it dy dx because at some point you're going to flip it over. I can't call it f prime because one of them is f prime, one of them is g prime. So the point AB is on f, which means what point is on g? BA. And the derivative, this is like the normal stuff, the derivative would just be f prime at A. That's the easy part. That's the part we already know how to do. But the derivative of g is 1 over f prime at A. They're reciprocals. So whenever I work one of these problems, I lay out the table and the question is almost always going to be asking me one of these two things. So I'll have enough information to get one of them, and the answer will be the reciprocal. So lay out the table, and I think it makes today a little bit easier. Some examples. If f of 2 equals 5, f prime of 2 equals 1/3, then what is the derivative of the inverse at 5? It's like, whoa, that's a lot. So let's make our table. It's not called g, it's called the inverse. So I'll just even write inverse. There's a point, and there's a y prime. So what point are we dealing with on f? 2, 5, right? X is 2, y is 5. And it tells me that the derivative at 2 is 1/3. Maybe I should specify y prime at the x value is 1/3. So the inverse point would be 5, 2. And y prime at the x value, y prime at 5, well, these two are reciprocals of one another. So what's my answer? 3. So that one you didn't really have to take any derivatives. It gave you all the information, and you had to, sort of organize all the stuff they give you to figure out what the answer is. Again, those two final boxes are always reciprocals, and that's the key to the problem. The trick is being careful, because the first derivative, or the derivative of f, is at x. The derivative of the inverse is at x, but those are different x's. So again, you got to keep track of who's x and who's y here. Number 2. If f of x equals 3x cubed plus 5, find f inverse at 8. Okay, let's organize our information here. Where does that 8 go? What is the 8? Oh, it's on the inverse. So is it the x or the y of the inverse? It's the x value, because it's the input, to the inverse. So it's right there. And what it wants me to find is that box right there. The derivative at 8, whatever that is. Okay, but I don't know the formula for the inverse, so I can't take a derivative. Instead, I need to work this sort of backwards, find the derivative of f, and flip it over. But before I flip it over, I need to worry about what x value I've got. So if 8 is the x value for the inverse, where does 8 go in this line of things? That's the y value. So if 8 is my y value, now I can figure out what the x value is from the equation. So 3 equals 3x cubed. Divide by 3, I get 1. Cube root, I get 1. So x equals 1. And the reason I'm doing that is I need 1 because I want y prime at 1 so that I can flip it over to get the derivative of the inverse at 8. So let's find the derivative. That would be 9x squared. And then the derivative at 1, because we're always talking about derivatives of x values. Would be 9 times 1 is 9. And then the last step is flip it over, and you get 1/9. It's a lot of algebra. It's a lot of organization of information. which is why I think the table is helpful. Number 3, let h be a differentiable function. Selected values of h and its derivative are given on the table of the right. Find the derivative of the inverse of h at 5. Again, let's make a table because this is crazy. There's just too much information going on. And again, the point of my table is that those last 2 entries will be reciprocals. So if I can know one of them, I can know the other. And what it wants is the derivative of the inverse. That's what it wants. But at what x value? 5. So 5 is the x value for the inverse. That means it's the y value for the original. If it's the y value for the original, how do I find the x value for the original? Look at the table. So what is the x value that gives me a y value of 5? 10. And now I'm close. Again, my main idea is these 2 derivatives are reciprocals. So if I can find one, I know the other. Well, I think I can look at the table and find the derivative of h at 10. The derivative of h at 10 is negative 1/4. And then if I flip that over, I get negative 4. So it's a lot of steps, most of them algebra. And again, the organization of information into a table is, in my mind, the only way to keep up with it. There's way too much stuff going on. I tried to draw arrows to help us follow, but that was 1 step, 2 steps, 3 steps, 4 steps. And any one of those is kind of confusing. So draw the table to figure this stuff out. Write the equation of the line tangent to the graph. So I need point and slope of the inverse when x is 7. H inverse, point, and you can call it y prime, you could just call it slope, you could call it dy dx. So let's set up our table. Where's the 7 go? It's obviously x equals 7, but is it x equals 7 for the inverse or the original? For the inverse. Right? See if you can finish out that problem. Really similar to the last with that extra step of writing the tangent line. 3, because they're switched. And the slope is negative 2/3. And so y minus 3 equals negative 2/3 x minus 7. But that last part's the easy part. The table part is the tricky part. But draw the table. Don't try to do this without the table because it's just a mess, I think. Let's do 4. I don't think we need to do 5 because it's another table problem with inverses. So let's do number 4 and then we'll be done. So if g of x is the inverse of f. So already I'm lining up my table here. F of x is sine of 3x, where x is between 0 and pi over 4. G prime at 1/2. Okay, so now I'm can start filling in my table. So where's the 1/2 go? Yeah, right. That's the x value for g. And if it's the x value for g, it's the y value for f. So it's the y value for f, 1/2 equals sine of 3x. So now I've got to do a little bit of trig to figure out what x would give me 1/2 as the y value. So the sine of what is 1/2? What angle has a sine of 1/2? Pi over 6. So that means I need 3x to be pi over 6. Yeah, that's right. If 3x is pi over 6, then the sine is 1/2. Divide both sides by 3, and I get pi over 18. So there's my x value that I was looking for. That also means it's the y value of g, but we may not need that. Okay, so if I can find the slope at pi over 18, then I'll just flip it over to get what I'm really looking for. I guess that's boxing too many things. Here's the answer I want, is this thing. So let's find the derivative, plug in pi over 18, and then flip it over. So y prime, derivative of sine is cosine, chain rule is 3. So at pi over 18, so the cosine of pi over 6 is root 3 over 2. So this derivative is 3 root 3 over 2. And then I would flip it. And before I think about fixing it, I start looking at my answer choices. And there it is, answer choice D. All right, assignments worksheet 4. Show the table, like that's showing your work. That table that we made, that helps you organize the information. If you don't show the table, there's just too many steps. For me, I can't do it without doing the table. I just get lost with x's and y's and who's x and who's y and who's flipped. Show the table. All right, quiz tomorrow, but again, the quiz does not have this stuff on it. So try some of these, we'll go over them, and then we got basically 2 days of review next week before we test.